You know, it's kind of wild to think back, isn't it? Before 2019, if someone said, hey, I photographed a black hole, you'd probably think, well, how?
Right. I mean, they're black holes. They suck in everything, light included. How do you photograph darkness?
Exactly. Seems impossible. But then, bam, 2019 happens, and scientists actually show us an image. It was pretty stunning.
Absolutely groundbreaking. And that's what we're digging into today using the source you brought. How did they manage it?
Yeah, we're focusing on M87, that supermassive black hole way out there in the M87 galaxy. What is it, 55 million light years away?
That's the one. An incredible distance. And that image, it really became iconic almost instantly.
It did, sort of a symbol of, I don't know, human ambition. So our mission today is to pull apart the key things that made this impossible photo happen.
And the scale is the first hurdle, right? The source uses the great analogy, picturing a donut on the moon.
Oh, yeah, I remember that.
And not just seeing the donut, but being able to see, like, the sesame seeds on it from Earth.
Wow. Okay, yeah, that puts it into perspective. The level of detail needed is just mind-boggling.
It really hammers home the precision involved. So how do you even build something capable of that?
Right. So clearly it wasn't just one enormous telescope sitting somewhere. That wouldn't work, would it?
No, not physically possible to build one big enough. The solution was, well, ingenious. It's the Event Horizon Telescope, the EHT.
Okay, the EHT.
Yeah, and it's not one telescope, but a whole network. They linked up 8 existing radio telescopes scattered all across the globe.
Scattered where? Like different continents?
Exactly. The source mentions Hawaii, Spain, Chile, even the South Pole. They essentially synchronized them.
So by linking them, they created a sort of virtual telescope.
Precisely. A virtual telescope, effectively the size of the entire Earth. That's how they got the resolving power, the sharpness needed.
An Earth-sized telescope.
Wow.
Okay, but getting data from telescopes in, Chile and Hawaii and Spain all in the same time, that sounds like a nightmare.
Oh, absolutely. The logistics were immense. We're talking years of planning.
I bet.
They had to synchronize everything down to nanoseconds. The timing had to be perfect.
To nanoseconds across the whole planet.
Yep. And then there's the data itself. Just vast amounts, petabytes.
Petabytes. You can't just email that, can you?
Not back then. Definitely not. The internet speeds just weren't up to it for that volume. So they actually had to physically ship hard drives.
No way. Like, put them on planes.
Exactly that. Piles of hard drives flown to central locations for processing. It's kind of old school meets high tech.
That's incredible. So it was this huge collaborative effort dealing with massive data, complex timing.
A real testament to coordination and, frankly, sheer will.
So beyond just getting the picture, which is amazing in itself, what did it really tell us? What was the big scientific payoff?
Well, it was huge for physics. It was basically a direct look at the environment right around a supermassive black hole.
Seeing the shadow it casts, right?
Exactly. And measuring that shadow, its size and shape, allowed scientists to test Einstein's theory of general relativity in extreme conditions like never before.
And did Einstein hold up?
Remarkably well. The observations matched the predictions very closely. It also gave us insights into how these giants feed that swirling disk of superheated gas around them.
The accretion disk. Right, so it wasn't just a pretty picture. It was packed with data.
Absolutely. Confirmed theories, open new questions, a scientific goldmine.
Okay, so let's recap. Taking a picture of something invisible like M87 wasn't impossible after all.
Nope. It took this massive global team up,
Creating that virtual Earth-sized telescope.
overcoming just huge technical and logistical hurdles like shipping petabytes of data around.
It really shows what happens when people work together on these fundamental questions about the universe, doesn't it?
It really does. Humanity, stuck on this tiny planet, managing to glimpse the edge of a cosmic monster millions of light years away. It's pretty profound.
It makes you think, though. What else is out there? What other invisible things might we be able to see if we keep pushing, keep collaborating like this?
That's the exciting question, isn't it? What's the next seemingly impossible thing we can make visible?